So now what we're going to do are some example problems from section 1.2. So first one is this function, or is this a function? So you have to look at what the domain and the range are. Now bearing in mind, for every x there can be 1 and only one y. So from -2 to 3 is fine. For -1 to 3 is fine. But the fact that -1 goes to both 3 and 4 makes this not a function. If you were to graph this out, at -1, right, x value -1, there would be not 1, but 2 y values, which would fail the vertical line test. Okay. Which sets of ordered pairs from A and B represent a function from A to B? So for instance, A mapping to 1 is fine, C mapping to 2 is fine, C cannot map to 3, meaning it's mapping to two different things. So this is not a function. A to 1, B to 2, C to 3. Turns out that is a function because it's not mapping from one to the other. So 1 goes to A. So what you're looking for is you want to look for repeats in the independent and see if it's repeating in the dependent. The fact that you get A out of 0 and 1 is okay. That's fine. If it was like A1, A0, that would be a problem. But right now, both B and C, in this case, are functions. Okay, evaluate the function at the specified value. So all you're doing is you're plugging in these numbers. So when you're doing f of -4, you simply plug -4 in for the variable, and then you simplify. -4 plus 8 is 4. Which is square root of 2 plus 2 is 4. That would be the fully simplified form for A. For B, you plug in 8. So f of 8 would be the square root of 8 plus 8 plus 2, which is the square root of 16 plus 2, which is 4 plus 2 equals 6. That would be fully simplified. For the last one, because there's a variable in what you're evaluating, there's going to be a variable over your answer, which is fine. So f of x minus 8. So you're going to plug in, and I would strongly encourage you to, x minus 8. You're going to plug in x minus 8, and I would do it in parentheses because you're plugging all of that in for the variable, then plus 8 plus 2. X minus 8 plus 8 turns out to just be x. And then it turns out that that is your final answer, fully simplified. X and 2 are not like terms. Similarly, we plug in 2, which means 2 times 2 squared plus 3 over 2 squared, which is 2 squared is 4 times 2 is 8 plus 3 over 2 squared is 4, 11 fourths. I just leave it as a fraction. You're done. B, Q of 0. So 2 times 0 squared plus 3 over 0 squared and undefined. Why? You're dividing by 0, which is a problem. You're actually done. C, Q of -x. I do want you to simplify this, so it would be -x. Now this is where you probably want to think of this as -x squared, meaning you're multiplying -x times -x. Same in the denominator. So 2 times, what's a negative times a negative? Why, it's a positive. This would be the same thing. Still plus 3, that doesn't just go bye-bye. What is negative? So it turns out that when you plug -x in, you get the same thing. That's it for that. Okay, 42, same idea, except now we're looking at piecewise functions. So you just need to figure out where you're at in the domain. So f of -2. Where is -2? Is it less than or equal to 0? Well, yes it is. So then you'd use this function, the function 1. The reason I picked that is because -2 is in this area here. Where is f of 0? F of 0. Everyone knows what the or equal means, so that means you're looking at that function again. So it's 2 times 0 plus 5 equals 5, and done. And C, f of 1, which means now we're looking at this area here, if that's greater than 1, right? So that would be 2 minus 1, or, wow, that was almost hard. Okay, these next couple, you are looking at the domain and the range. Key thing when you're looking at here, when you're looking at the numerator, it could be anything positive or negative, that's fine. Key thing is, you're dividing by y plus 5, when does it equal 0, and y equals negative 5. Which means that when you plug y in, and I know it's y, but it's still the domain, because it's the independent variable, the domain would be from negative infinity up to, but not including 5, along with not 5 all the way up to infinity, so everything except 5. And then for the range, it turns out because we're dividing by this, is there any way to take a number and divide by y plus 5 and ever get a value equal to that? No. So it turns out that we end up with a, and oftentimes if you look at the graph, this can help you out, it ends up being the case that we cannot ever reach 0, because we can't divide by a number large enough for us to ever reach 0. Okay, this next one's kind of a combination. In addition to when is 6 plus x equals 0, because that's a problem, there's also a problem with the square root of x plus 6. Can I take the square root of a negative number? No. So x equals negative 6 would be when I'm dividing by 0. And here, if I take, so when is x plus 6? When is that greater than 0? When x is greater than, or supposed to be equal to, negative 6. So what does this mean? It means that if we plug negative 6 in, it blows up. That's a problem for our domain. And also, if we were to take anything larger than negative, sorry, the x would have to be larger than negative 6. Anything smaller than negative 6, it's like negative 7 plus 1 would be negative. That's the problem. So it turns out that we're just looking at negative 6 and higher. Both the square root and the denominator play into it, but it turns out that the square root eliminates what would have been okay for the denominator. Range. What is the lowest value this function could be? Well, if you plug negative 6 in, then what happens? Ooh, wait, I should not include negative 6. Bad. Because if I do include negative 6, what happens? I'm divided by 0. So I'm not including negative 6. That's my start point. So anything like negative 5.999, that's fine, because otherwise the denominator would be a problem. And that being said, when I divide, what happens? I plug something like 5.99 in, I get a very small number divided by a number. So graphically, what am I looking at? I'm probably looking at a boundary of 0 and infinity. And we can confirm that with graphing. And that concludes section 1.2.